When you're graphing inequalities from slope-intercept form, you want to graph the line as if it were an equation. Now, remembering that the line itself is going to be all ordered pairs that make the equation equal, so both sides would be equal to each other. Now, when we're doing inequalities, maybe they can be equal, maybe they can't be equal. So if you are allowed to have equality in the inequality, so like if you don't care if it's greater or equal or less or equal, then you would use a solid line. So a solid line would be your greater than or equal to or your less than or equal to. If it's not allowed to be equal, but it must be only greater than or less than, then we would use a dotted line or a dashed line to indicate that that's the barrier between the points that do and do not work. But the line itself, the points that make both sides equal to each other, would not be part of the solution set. So if we're looking at y is greater than or equal to 2/3 x plus 4, we're going to graph that as if it were an equation. So we'll start at 4 and do a rise and a run of 2/3, which would look like this. Now once you have the line, since ours is greater than or equal to, we can make this a solid line because it includes all points on the line as well as points that make it greater. Now when we're looking for greater, that should be that we're shading above. So if it's greater or greater than or equal to in slope-intercept form, then we should be shading above the line. If it were less than or equal to with the symbol, we would be shading below the line. All y values that are less than that line, or all y values that are greater than that line. And so with ours being greater than or equal to, we should be shading above. But to verify, I'm going to pick a point that is above the line, and I'm going to see if it makes the inequality true. Now, when you do this, you want to check easy points. Let's don't check things that make our life more difficult. We want to check things that are easy to substitute in. If you can do like 0, 0, that's super easy to plug in. 0, 0 here is not above the line, so I'm going to pick one on the y-axis but above. So I'm going to pick 10, 0 or 0, 10. And I'm going to take my inequality here and I'm going to replace x and y with that ordered pair. So for y, it'll be 10, and for x, it would be 0. And I'm just going to see if it's true. So 0 times 2/3 is 0, and then 0 plus 4 is 4. So I get down to this inequality statement that says 10 is greater than or equal to 4. Well, that's true. So that means that 0, 10 is a solution to this inequality. Therefore, every other point in this area should also be a solution. So I would shade the top part of this line to indicate that anything on the line would make it equal, and we're okay with that. And anything above the line would make it greater, and we're okay with that. So any of those points would be a solution to this inequality. Let's say that I had picked 0, 0. Just to see what that looks like. If I had replaced y and x with 0 for each of them, then I would end up with this statement here, which says 0 is greater than or equal to 4. Well, that is a false statement. 0 is not greater than 4. And that's why we wouldn't shade the side where 0, 0 is located, because it's not a solution. Now, if we look at this one here, we have a less than symbol, not a less than or equal to. So we're going to graph it just like it's a regular equation. We'll start at 1, do our slope here of -2. So we're going to do down 2, over to the right 1, or up 2 and over to the left, just like we did with equations. Since it does not include the line, I don't want to make it a solid line because, again, the line itself is when the points are equal. This is not allowed to be equal. Then what I'll do here is I would then say, well, it's supposed to be less than. Well, that should be anything below the line. So let's say that I was going to pick 0, -5. Or even 0, 0 would be below the line, but it's pretty close. So I'm going to pick 0, -5. Then I'm going to replace y with -5 and x with 0. and I'm going to see if that's true. So is negative 5 less than 1? Yes, that is true. And so the points that make this inequality true are all ordered pairs below the line of negative 2x plus 1. And so those would be the solution set, which is why we're shading it. Here on this one, my symbol is greater than, again, not greater than or equal to, so it would be a dashed or a dotted line. It will not be solid because the line itself will not be part of the solution. I'm going to start at negative 5. My slope is going to be 1 because it's 1x, so that's up 1 and over 1. And then I'm going to decide, should I be shading above or below that line? Well, greater indicates that it should be above, so I'm going to pick a point above. In this case, I will pick 0, 0. And then I would have 0 for y is greater than 0 for x minus 5. So that 0 is greater than negative 5, which is true. 0 is greater than negative 5, so that point does work. That means all of these points above this line of x minus 5 should create a y value greater than x minus 5. So that's my solution set. So this is how you would graph from slope-intercept form.